Section 10.6 is conics. And there are three types of conics. They are parabolas. You guys have all seen parabolas before. Ellipses. Have you seen ellipses before? Okay, and hyperbolas. Now, if you haven't seen ellipses and hyperbolas, then you probably haven't seen parabolas from the perspective we're going to look at them today. Okay, the perspective we're looking at today relating to conics includes all three. So if you haven't seen those last two, you haven't seen this particular perspective about parabolas. But we're going to start with parabolas. A parabola is actually defined to be the set of all points that are equidistant from a fixed point, called the focus, and the line called the directrix. There's a special point on the curve, depending on what point you printed this off, your paper may say line, so scratch out the word line if it says that, it should say curve. A special point on the curve that's called the vertex. And this is actually the midpoint between the perpendicular line from the focus to the directrix. And a picture will do so much better than any of that language does. Now, I am a big fan. I really enjoy conics because I don't use any of the equations. We're going to see a whole bunch of equations in this section. I don't remember any of them. I'll be honest with you. I don't use any of them. I always go back to the picture because from the picture I can create whatever I need. So I'm going to be drawing a lot of pictures in places where your book may not say to draw a picture. It may not, describe it in that way. But to me, it makes a lot more sense than memorizing a whole bunch of formulas. So you're going to see me drawing a lot of pictures in this section. There are two different kinds of parabolas we can look at if we're not focused or worried about the fact that they're not functions. So one parabola will look like this, either opening up or down. I'm just going to draw the up version of it. The other one will open this way, or it could be opening to the left. Okay, so these are the two different forms for this. On this form, your vertex, of course, is this particular point right here, and over here the vertex would be this particular point. So depending on the curve you're looking at, it's either a maximum or minimum location. So that's some calculus language for you. I told you we weren't going to do any calculus in there. I go talk about maximums and minimums. Okay. The focus is going to be on the inside of the parabola. And it's at a specific place, so I didn't just randomly put it there. I mean, I did, but there's an actual specific location for what the focus would be. The focus actually determines how wide or how narrow the parabola opens. That's what it's determining. Okay. And then the directrix is an equal distance away on the other side. So the directrix on this first picture would be down here, and the directrix on this second picture would be over here. Now, what I should have drawn, if it's drawn well, is something where these two distances in purple are the same length, and these two distances over here in purple are the same length. So visually, it's not too far off, I think. I'm convinced that it looks at least reasonable. Now, in terms of your picture, I've described what each of these are. We'll label them. This is my focus. This is my vertex. This is my directrix. And you can label the same thing over here. Focus, vertex, and directrix. And I'm going to be showing you something here in a moment, and some textbooks will actually call this length right here, they'll give this length the name P. Your book doesn't do that, which I'm actually pretty fond of because there's no need to involve another letter in the situation. They're actually going to reference this as being 1 over 4a, which will actually make the formula look a lot more like the one that you're most familiar with for parabolas anyway. So this length right here is 1 divided by 4a. So obviously it's the same as the length here. This is also called 1 minus 4, or 1 divided by 4a, and this is this one. So they're all 1 divided by 4a. All right, so I am going to show you all the formulas because if you really enjoy looking at things from an equation perspective, you can do that. Theorem 6.1 tells you that if we have a parabola with a vertex at the point B, C, and a focus at the x value B, and then the y value is C plus 4a. Okay, so it's that increase of 4a, the distance away. We have a directrix given by the line C minus 1 over 4a. Then we can describe the equation of the parabola itself as y equals a times x minus b squared plus c. And there's pieces of this that look very familiar already. In fact, this equation should look familiar. And there's nothing about that equation that you haven't seen before. There's the B and there's the C that are the vertex, right? You've looked at that from perspective before. Here's the A at the front, which we call amplitude. And the A is actually measuring, at least it's in relationship to how far away the focus and the directrix are. How would this parabola be opening? Up or down, depending on what the A value was. If the A value is positive, it opens up. If the A value is negative, it would be opening down. Okay? Here's our second possibility then. Our second possibility is we have a parabola, excuse me, with the vertex at CB. The focus is C plus 1 over 4A. So notice it's the X value that's changing on this. The Y value remains constant at the B value. The directrix is a line X equals, which means it's a vertical line, C minus 1 over 4A. So the same C value that we got from the vertex, but it's minus 1 over 4A, minus that little distance. And we end up getting an equation that's X equals A times Y minus B squared plus C. Now, your vertex is still in here at CB, right? The C is the X value, correlating to the X value, and the B is the Y value. It's correlating to the Y it's next to. This is the type of parabola that opens how? Either left or right. And it depends on A. If the A value is positive, I didn't write this in the last slide because you guys are very comfortable with it, but if the A value is positive, this opens to the right. And if the A value is negative, then it opens to the left. We don't use these particular parabolas as often because they aren't functions. So when you're dealing with functions back in like college algebra, you wouldn't be dealing with this type of parabola. All right, so what we're going to do is we're going to take a context where we're given some information about a parabola, and we're going to actually create the equation. And you can do it from these formulas and everything that they do in here, but like I said, what you're going to see me do is to draw a picture, because I can see it in the picture without ever having to work with any equations. It's just going to fall into place. So that's how I'm going to take this this perspective. We've got a parabola. The parabola has a focus of 2, 0. So I'm just going to draw it. I've got my xy axis. My focus is at 2, 0. So I'm going to draw in some lines here. I'm going to do measurements of 4 away. All right, so I've got a point at 2, 0, which would be here. I'll draw it in red. That is my focus. The directrix is the line x equal negative 2, so is that a vertical line or horizontal line? It's a vertical line. Over here, right? Now, those two pieces that I just drew in red are not actually on the equation of the parabola. The focus and the directrix are not a piece of the parabola itself. But halfway between them, where would I be? We'd be at the origin. So this graph right here has this particular point, the origin, and that's my vertex. It's halfway between. So now I know my vertex. My vertex, it doesn't specifically ask me, but I'm going to need it to create my equation. My vertex is 0, 0. How will this open, right or left? To the right. How do you know? Yeah, it opens with the focus on the inside. It opens so that it doesn't cross the directrix. So it has to open right. This distance right here, what is the length of this distance between the vertex and the focus, or the vertex and the directrix? It is 1 over 4a. What is it in our particular graph? It's 2, which means I should be able to solve this to figure out what a is. What is a? It's 1/8, isn't it? It's 1 over 8. And you can, multiply and divide and simplify that out if you need to see the pieces, but 1 over 8 will do it for us. That's my a value. So my equation is an x equals equation because this is a parabola opening sideways. I've got y minus something squared plus something else. Well, these pieces right here are my vertex. My vertex in this particular graph is 0, 0. So this is y minus 0 squared plus 0. And the value in front is the a value that I just found. It's 1 over 8. So if I simplify, this is x equals 1/8 y squared. And I don't need any of the formulas about what the vertex or the directrix is in relation to the graph because I can see the graph. Does that make sense? Okay.